Hi, I'm just reading our energy and chemical reactions test. So here I'll put in my name and click next. So this is the energy and chemical reactions test. This test, in each question, imagine a group of students. A teacher asks these students to use what they know about chemical reactions to create things. Energy and chemical reactions test, question 1. The teacher asks the students to make cold packs. The cold packs are made with chemical reactions. The chemical reactions used should absorb or take in heat energy. They need a chemical reaction that will make the cold pack 0 degrees to 4 degrees Celsius in a 25 degrees Celsius room. The teacher gives them the table below. Which reaction should they choose? So we have 4 reactions to choose from. 1, 2, 3, 4. And we see that it's chemical reactions, thermal energy is either released, absorbed, released. The amount required to produce the reaction is 100 kilograms, 10 kilograms, or 10 grams, 3 grams, 5 grams, and then the substance produced is either harmless gas, water, toxic gas, or water. So to make a cold pack, they should choose which chemical reaction, 1, 2, 3, or 4. So we're going to choose 1. Then it says, question 2. The teacher asks students to use a chemical reaction to make a meal ready to eat. Meals ready to eat are meals used by soldiers who are traveling. So you see soldiers and they're traveling and they've got these meals. The meals have a heat pack to keep food warm, so they don't have to cook them. The teacher gives the students the table below. Which chemical reaction should they choose? So we have this table here, and again we have 4 chemical reactions. And it says temperature change, and we see the temperature changes, how long the temperature changes, and how long the temperature is changing. And then we say, it says to make a hot pack, the students should choose 1, 2, 3, or 4. And which of the reactions is an exothermic chemical reaction? So we choose which one's exothermic. 1, 2, 3, or 4. So question 3, the teacher asks the students to use a chemical reaction to make something to make drinks colder. Something like this that would make drinks colder. The teacher says it should do 4 things. It should make the drink 15 degrees colder. They should use less than 50 grams of chemicals. The products should not hurt anyone. The reaction should be less than a minute long. So we've got the student, and one student thinks she's got it right. She puts 30 grams of one chemical with 25 grams of another chemical. The reaction gets 15 degrees colder in 30 seconds. So what did she do wrong? She didn't get it right. What did she do wrong? She either didn't get at least 15 degrees. She used more than 50 grams of chemicals, or it was dangerous and could hurt someone, or it took longer than a minute. So which one of these things did she do wrong based on this description up here? Question 4, the teacher makes the students create 9 chemical reactions. And here we have them, all 9 of them. In each reaction, they put together reactant 1 and reactant 2. So they're pouring 2 reactants together. In each reaction, they use 25 grams of reactant 1, so every time reactant 1 stays the same. And then they change the amount for reactant 2. So they're putting different amounts. You see 0 grams of reactant 2, 5 grams of reactant 2, 10 grams of reactant 2, and so on and so forth. And the students graph the temperature change in each reaction. So here we have the temperature change in each of these 9 reactions. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we see the temperature change. If the students want to get the most heat out of the smallest amount of reactant 2, how much reactant 2 should they use? Should they use 10 grams, 15 grams, 20 grams, or 25 grams of reactant 2. Question 4. So evidence of a chemical reaction. This one's a little different. It says, you got this chemical reaction here. It says, you see a chemical reaction. How could you find out if it's absorbing heat or giving off heat energy? So is it absorbing heat or giving off heat energy? You could weigh it before and after the reaction. You could take the temperature before and after the reaction. You could look for light and listen for sound, or you could time the reaction. So are you going to weigh it? Are you going to take the temperature? Are you going to look for light and sound, or listen for sound? Or are you going to time it? So those are your choices. And the final question here, question 6. The students make one chemical reaction. They put 2 chemicals together and take the temperature the whole time, and then they graph the reaction. So the students put the 2 chemicals together, and then they have it, they're taking the temperature, and they time it, and then they graph it. So here we have this graph that they made based on that. They have the temperatures, and they have the time. Is this graph exothermic, or is it endothermic? And that's the last question, and so we'll fill that out, and we hit submit, and you've taken the energy and chemical reactions test. Have a great day.